Howdy. So I hope you find the discussion in previous videos clear enough. So last time we started part 3 and we discussed how to apply Laplace transform to solve differential equation with the initial condition. So today we will continue to practice more examples. So here is the idea how to apply the theorem, how to apply Laplace transform to find solution. So first step is to apply Laplace transform to the given differential equation. And then we will get equation in letter S and capital letter Y. Second step is to solve the equation for capital Y. And then last step is to take inverse transform to this previous equation to get small y equals whatever. So for this process, we apply all the theorems and table and all the techniques that we have learned. All right, so before starting new problem, let me fix a typo. In problem 3, I ended up having typo. So look at this characteristic equation part in the box. So in this characteristic equation, we had root plus minus 1. So complementary solution must be linear combination of e to the t and e to the negative t, not e to the 2t. So let me fix this. This should be negative t. Thanks, Andrew, for fixing this typo. Extra credit. Yeah. So if you find any typo or any mistake, let me know to get extra credit. All right, so last time we finished the problems up to number 4, and then we will continue to practice this number 5. Okay, so step 1 is to apply Laplace transform to this differential equation. So Laplace transform of y double prime plus 4 times transform of y equals t. And then you can replace the first term by some expression in S and capital Y. So this Laplace transform is S squared y minus S times y of 0 minus y prime of 0. Good. And then the next term is simply capital Y. Oops, I meant L of t in the right-hand side. So the transform of t is 1 over S squared from the table. Good. And we can use the initial condition. The initial condition says everything is 0. So y of 0, y prime of 0, they're all gone. So we can simplify. So S squared plus 4 times capital Y. This is our left-hand side, and our right-hand side is 1 over S squared. Good. And step 2 is to solve this equation for capital Y. So capital Y is 1 over S squared times S squared plus 4. Good. So we are done with up to step 2, and in the next step you want to take inverse transform. So that's why you want to decompose this right hand side, and actually you already found the decomposition. So in homework 5, number 5, you found the decomposition, which is 1/4 1 over s squared minus 1 over s squared plus 4. Good. So this is from homework 5, number 5. All right, now that we found the decomposition, we are ready to take inverse transform. Inverse transform of capital Y is inverse transform of this right-hand side, this whole thing here. So by the linear property of the transform, you can take inverse transform of each term. So this is going to be 1/4 of inverse transform of 1 over s squared minus, well, if you want, you can use big parentheses like that, inverse of, look at this denominator, s squared plus 4. This 4 happens to be 2 squared. So we have s squared plus 2 squared. Now that we have s squared plus 2 squared, you want to have certain number, 2. So that's why we need to multiply 1/2 to give the identity. Now you can use the table. So the table says inverse transform of 1 over s squared is simply t. And then 2 over s squared plus 2 squared. That fits into sine kt, where the k equals 2. So this is sine 2t. That's it. So this is the unique solution. Good. I hope this discussion is clear enough so that you see the structure. In step 1, you apply Laplace transform to the equation and then use the initial condition y of 0, y prime of 0, and then you solve this equation for capital Y, and then you take inverse transform. For each station, sometimes you need to use table, linearity, first translation theorem, second translation theorem, and their inverse forms as well. Okay, so here's a quick remark. Actually, this is a second order non-homogeneous equation, and we once discussed how to find general solution and then unique solution. So characteristic equation is r squared plus 4 equals 0. That means r is plus minus 2i, right? So that those complex roots will give you certain complementary solution. The real part is 0, imaginary part is 2. So complementary solution is combination of cosine guy and then sine guy. And then you look at this right-hand side. Right-hand side is t, so you can come up with some guess for the particular solution, at plus b. So once you add them up, you will get general solution and then unique solution. So once you plug in this y sub p into the equation, you can determine a and b. Look at this unique solution from Laplace transform. So t guy has coefficient 1/4, so a turns out to be 1/4, b is 0. And then you use initial condition, y of 0 equals 0, y prime of 0 is 0 to determine C1 and C2. For this, you plug in your solution and derivative of your solution, second derivative of the solution. So this calculation may be quite long and tedious. However, this Laplace transform machine gives you unique solution right away. So it's quite fun to compare two methods, and in the exam, you can choose your favorite method. You can use any method, so it's completely up to you. All right. And then number 6. Okay. So first step is to apply Laplace transform. So Laplace transform of second derivative. Oops. Transform of derivative, then 9 times transform equals transform of e to the 3t. Good. And again, you can replace the first term by some expression in s and y. This is s squared, capital Y, s times y of 0, y prime of 0, and then this transform of derivative is s times capital Y minus y of 0. And we need parentheses like that, plus 9 times capital Y. So this is our left-hand side, and our right-hand side is 1 over s minus 3 from the table. Good. And now we use this initial condition. Y of 0 equals 2, y prime of 0 equals 6. So this is 2, this is 2. So if you plug them, we have 1, 2, 3 terms containing capital Y in the left-hand side, and let's move everything else to the right-hand side. So capital Y times s squared, and then minus 6s plus 9. Good. And then if you move everything else to the right-hand side, we have s times y of 0 or 2s. Good. Oops. Plus 2s. And then y prime of 0 is 6 plus 6. And then minus 6 times minus y of 0. Or 6. Let's see. So 6 times 6. Times 6. Let me check my note. Numbers are not exactly same as in my note. Let's see. Oh, now I see. This y of 0 is 2. Sorry. This y of 0 is 2. Okay, good. So let's pause. It's time to pause to see this, to to take a look at this right-hand side. This right-hand side is quite long, 1 over s minus 3, and some expression. Let's simplify this a little bit. This guy is 2s plus 6 minus 12. 2s minus 6. Good. So basically we have 1 over s minus 3 plus 2s minus 6 in the right-hand side. So eventually, you will solve this for capital Y and then take inverse transform. Now that we have very long expression, we need to keep it organized and simple as possible. So if you look at this left-hand side, we have s squared minus 6s plus 9, which happens to be s minus 3 squared. Now look at the equation. You see copies of s minus 3 squared, and then two copies of s minus 3 in the left-hand side, and then your right-hand side is 1 of s minus 3, and then look at this. This is, again, multiple of s minus 3. Good. So if you use this factoring, now you see pairs of canceling. This s minus 3, s minus 3, s minus 3. So this is one way to keep it organized and simple. All right, so we have 1 over s minus 3 plus 2 s minus 3. Good. Step 2 is to solve this equation for capital Y. If you divide everything by this s minus 3 squared, we have 1 over s minus 3 cubed plus, and then you have canceling pair, 2 over s minus 3. Good. So again, let me quickly remark how to handle this long expression in the right-hand side. Sometimes your right-hand side may contain several terms. You need to find a way to keep it organized or simple. So here we use the factoring. One quick hint is s minus 3, copy of s minus 3 in the left-hand side. Okay, so then next step is to take inverse transform. Of course, you can take inverse transform one by one. And the first term in the right-hand side is the problem given in quiz 6 yesterday. Well, for this first term, we read that as translated version. So we read that as something over s cubed, where you replace s by s minus 3. Now that we have s cubed, you want to have 2 factorial. Then you'll be ready to use the table. That's why we need to multiply 1/2 there, like this. Okay, and then the second term is obvious, plus 2 e to the 3t from the table. Good, just one more line. So it's going to be half. Inverse of this guy is t squared. And then this replacement will give you extra exponential function. Let me use color. This -3 and 3. The inverse form of first translation theorem says inverse of this translated version is inverse of this input together with extra exponential function, like this. Okay, plus 2 e to the 3t. That is the unique solution. So we are done. Number 6 is quite an advanced problem in a sense that this right-hand side is quite long. Okay, and then number 7 and 8. I picked number 7 and 8 to compare 3 problems, number 6, 7, and 8. The left-hand side is the same. Y double prime minus 6y prime plus 9y, the same. Right-hand side is also similar, e to the 3t, t e to the 3t, and t squared e to the 3t with the same initial condition. All 3 problems are very similar. The only change is you multiply copy of t to e to the 3t and then t squared to e to the 3t. So the solutions will be slightly different. So it's quite fun. It should be fun to compare result. Now that the left-hand side is the same, let me skip the details, but quickly write the result. So your left-hand side is going to be s minus 3 squared times capital Y. Oops. And your right-hand side will be slightly different. So your right-hand side is going to be 1 over s minus 3 to the 4th plus 2 over s minus 3. So if you simplify your equation in S and capital Y, you will get this equation. And step 2 is to divide everything by s minus 3 squared. So then, oh, sorry, this is typo. I meant 2. So this should be 2. Sorry. So previously it was 1, s minus 3 to the 1 in the denominator. Now we have s minus 3 to the 2. Now you solve this for capital Y. Then we have s minus 3 to the 4th plus 2 over, let's see, 2 over s minus 3. Good. And then step 3 is to take inverse transform, inverse of something over s minus 3 to the 4th. So the second term is quite easy, quite straightforward. For this first term, again, you want to use first translation theorem. So you read this expression as translated version, something to the 4th, where you replace s by s minus 3. Now that you have power 4, you want to have 3 factorial. Then you divide everything by 3 factorial, like that. And then, of course, the second term will give you 2 e to the 3t. So then you can solve this. I mean, you can find its inverse transform. So 1 over 3 factorial. Inverse of this is t cubed. And then extra exponential function. This is the unique solution. So if you compare that solution with the previous one, the only change is t cubed here, right? And well, actually this change is not surprising because The characteristic equation is r squared minus 6r plus 9 equals 0, r equals 3 with multiplicity 2. So your general solution is going to be C1 e to the 3t, C2 t to the 3t, right? And then for particular solution, you want to try a times e to the 3t, right? But somehow, if you, well, of course, this will not work because the complementary solution contains a copy of this. Then you keep multiplying t. Of course, again, this is in complementary solution, you keep multiplying. It turns out that you will need somehow power 3 instead of 2. So it turns out that your a is 1 over 3 factorial. So the point I want to make is that you can use this previous method, but it may take long time. So for example, to figure out which particular solution would work, you may need to calculate all the details. So it may take a long time. But Laplace transform is a very nice method to find a unique solution quickly. All right, number 8 is quite similar. The left-hand side is the same. If you take Laplace transform, you will get s minus 3 cubed, sorry, squared. Capital Y equals 2 over, let's see, yep, 2 over s minus 3 cubed plus 2s minus 3. Good. Step 2 is to solve this for capital Y. S minus 3 to the 5th. All right, the same as before. The only change is this first term. And then you take inverse transform. Then you will see what you need is 1 over 4 factorial t to the 4th e to the 3t plus 2 e to the 3t. By the way, you will let this 2 as well. I mean this 2. Yep. So this is the unique solution. Again, the point is, if you want to solve this using the previous method, I mean, the previous method, which is based on your guess. I mean, if you want to find solution like this, complementary solution plus particular solution, then you want to come up with some guess for this particular solution. But it turns out that you will need t to the 4th. Remember, this method is quite naive and it's just based on your guess. If your guess works, that's great. But if your guess doesn't work, you keep coming up with a better guess. So it's not obvious to use such guess in the beginning. So you try this and that things to figure out this y sub p. It may take a long time. However, Laplace transform has an advantage that gives you unique solution right away once you finish it. So it's quite good machine. All right, and then one more. Problem 9. This is a really good problem. We need to solve this very carefully. Look at this right-hand side. It's very long function, e to the something, and trig functions. It's quite difficult to come up with a particular solution, right? How you come up with a particular solution? It's quite difficult. Even when you try this particular solution, it may take even longer time to figure out your particular solution. So let's apply Laplace transform. So Laplace transform of well, let me skip the obvious first step. I mean the first line. If you apply Laplace transform, I think you already got used to the first line. So if you apply the Laplace transform, then you use this initial condition. Then you simplify your equation to have s squared plus s. Now that all the initial condition is 0, the only left-hand side is those two terms. And then your right-hand side is transform of this guy, whole thing. And you use first translation theorem. So you can think of distributing one by one, but you can keep it as it is. So first translation theorem says the transform of function together with extra exponential function, it is translated version where you replace everything, every s by s minus 1, right? Okay, so it's going to be, well, from the table, we see this is 2s over s squared plus 1 minus 1 over s squared plus 1. Probably you need this big parenthesis because this replacement applies to every s. So it's it's going to be very long. So let me rewrite this to save space. It's going to be quite long. Sorry. Let me rewrite this here. So it's going to be 2s over s squared plus 1 from the table. And then you replace every s by s plus 1. Whew, scary. So replace every s by s plus 1 here. Again, it's time to pause a little bit to keep it organized. So you can keep it separated as it is. On the other hand, you put them together because common denominators. You have common denominators, you can put them together. So 2s minus 1 over s squared plus 1, where we replace s by s plus 1. Very good. So 2s plus 1 minus 1 over s plus 1 squared plus 1. Quite complicated, but it's simple enough. So step 2 is to solve this equation for capital Y. Now that s squared plus s is s times s plus 1. You can use this factoring. If you divide everything by this product, capital Y is your right-hand side over s times s plus 1. Probably, let me use bracket instead of this. Come on. So this is our denominator. What about numerator? You distribute or simplify 2s plus 2 minus 1. So 2s plus 1. Very good. And then eventually you want to decompose that, right? And actually you already found the decomposition. So look at this denominator. We have product of two distinct linear factors. So that's why we have something, sometimes 1 over s, and then something else times 1 over s plus 1. And then this quadratic factor is irreducible. As you see there, this has no factoring at all. So you can keep it as it is. So s plus 1 squared plus 1. So eventually we need this expression, complete a perfect square plus 1. So let's keep it as it is. And then some linear term. What's the decomposition? Let me, so it turns out that you need 1/2 and then 1 and then minus, I don't like this number, minus 3 over 2 s minus 2. So you already found this in homework 5, number 7. Good. And eventually you want to take inverse transform of this guy. Fantastic. So first two terms in the right-hand side are easy. If you take inverse transform, you will get 1/2 times 1 plus e to the whatever. It's quite easy. This big chunk is real worry. So we need to take inverse transform very carefully. So the idea is, look at this s plus 1 squared. So let me rewrite this here. So eventually, looking at this as plus 1 squared, you want to read that as translated version. Some big expression where you replace s by s plus 1, right? This is what we want. So this denominator will be s squared plus 1, and then s squared plus 1, and so on. So this is what we expect. Again, look at this expression inside the big bubble. So we want to read this as a translated version, s squared plus 1, s squared plus 1, where s is replaced by s plus 1. Good. We need to find these numerators carefully. So what we want is, well, let me write this denominator s plus 1 squared. So that's why we want to have copy of s plus 1 in this numerator as well. It would be great. Then eventually we read that as translated version like this, s over s squared plus 1, where s is replaced by s plus 1 and so on. Okay. However, on the other hand, we want to keep the identity. So we want to rewrite this expression in the bubble like this. And so here is the rewriting. This is kind of advanced level, but it's doable. So on one hand, we want s plus 1, copy of s plus 1 in the numerator. On the other hand, we want to keep this blood red coefficient. So you take this coefficient here with parentheses. Don't forget to put parentheses like that. And then you control number here, plus or minus, whatever. So you can control this number so that two guys are the same. Then we'll be done. Okay, if you distribute, we have negative 3 helps s over there. And then negative 3 helps minus something is negative 2. You can determine this number. Yes, we need negative 1/2. Good. And we are ready to read everything as translated version. So s plus 1 now becomes s, and you keep this number, of course. Oops. Negative 3 over 2. Good. And then we split this into 2 pieces. First part, minus half. Probably let me use color again, purple. This guy is now 1/2 here. Good. Then 1. So we are done. So somehow we tried to rewrite this expression in the bubble to read that as translated version like this. Let me put that inside the big bubble. Okay. And then next step is to take inverse transform. Inverse transform is, remember we had the 2 more terms in step 2. So this half times inverse of 1 over s, inverse of s plus 1, and then inverse of everything. So let me write that carefully. Oops. Inverse of negative 3 over 2 s over s squared plus 1 minus half. 1 over s squared plus 1 with the replacement s by s plus 1. Fantastic. And so first term is just 1, half times 1, and then e to the negative t. Now, now you use inverse form of first translation theorem. So this replacement will give you extra exponential function e to the negative t. And then you take inverse of those guys, right? You take inverse of those guys. I need more space. Plus. So inverse of this is negative 3/2 cosine. And then inverse of this is negative half sine guy. Good. This is unique solution. Finally, we are done. Yes. Beautiful. So this is quite an advanced problem, especially the right-hand side. The expression in the bubble, this big bubble, is quite difficult. Well, in the exam, I try to choose problem carefully so that your numbers are whole numbers, not like 3 halves or 5 halves, whatever. So numbers will be easier, but you should be able to read this expression as translated version like this. It may take some time, but you need to practice this algebra of rewriting. Then once you read that as translated version, you apply inverse form of the theorem, first as translated theorem. Then you can find the unique solution. So this problem number 9 is quite an advanced problem. And good problem, of course. One more remark. What if I give you a problem like this in the exam? Are you going to try to use this guess, y sub p, particular solution? It may work, but it may take a long time. I think Laplace transform is a better method for this problem because particular solution is quite difficult to find. Okay, so number 9 is a really good problem that you need to practice. Okay, I hope I hope everything is clear, and if you have any question or if you have any fine typo, please let me know. You can send me an email quickly. All right, thank you very much.